A failed experiment with Rust static dispatch. Are you guys ready for this one? Initial versions of the end basic service, and therefore initial versions of end tracker, use dynamic dispatch to support abstract definitions of system services such as the database they talk to and the clock they used. This looks like a bunch of arc-dyne-foo objects passed around and was done to support extremely fast unit testing. This is funny that we just got done watching the old code aesthetics video on testing and dependency injection and all this. This is kind of like one of those things that could be kind of similar, you know, in the Rust world. If you have like a database connection, a database item, and you need to pass it between multiple threads, you end up having some sort of, you know, but you want to be able to test against it and not actually use the database. You end up having these like dyne-foos, these arc-dyne businesses. So this, let's hear the other side. Let's hear the other side of this story. You ready for this one? It kind of started off, this article kind of started off just like right in the deep end. Okay, I like it. When I generalized the core logic of these services into the 3-4 framework, I decided to, I don't know what the 3-4 framework is. I decided to experiment with a switch to static dispatch. The rationale was that using static dispatch better aligns with the design of well-regarded crates in the Rust ecosystem, and also because I wanted to avoid unnecessary runtime costs in the foundational pieces of my web services. This is good. Obviously, dynamic dispatch will never be as fast as static dispatch. Static dispatch is literally just like go here and go. Go. Do the thing. Right? Let me tell you that this decision was a huge mistake, and that experiment has utterly failed. Using static dispatch has been a constant source of frustration due to the difficulty of passing types around and reasoning about trait bounds. Safety. The situation has gotten so bad that I dreaded adding new functionality to my services whenever a change to a statically typed struct was needed, because that meant yet another type parameter and plumbing through tens of source files. Oh man, it's kind of like the generic explosion. You know, the moment you need or a lifetime explosion, the moment you need to do a lifetime, the emotional pain that is Rust to do a lifetime after you've built something. Oh my goodness, it just kills you. Yes, OCaml would be the savior at this point. In lieu of the difficulties, which eventually turned into blockers to implementing new features, I made the choice of going back to dynamic dispatch. The goal was to gain ergonomics at the expense of supposedly negligible runtime costs. Let me tell you about the problems I faced, the refactoring journey, and some measurements I gathered after the rewrite. Ooh, this is great. Okay, this is great. This is exciting, right? The adaptation of static dispatcher in 3.4 started pretty simple. It did the job well. Even though it took me days of fighting with the Rust type system, I eventually got it to work. The production binary was statically bound to the Postgre database backend, and the unit tests were bound to SquealLite. Let's go, file testing. Let's go! SquealLite! So good. All the while respecting type safety offered by SquealX, and without having virtual function calls anywhere. Let's take a peek at what the sample key value store code pieces looked like by going through the architecture layers described in MVC, but for non-UI apps. At the bottom layer, the database was the transaction trait to supply the operations required by the business logic. Okay, cool. So trait TX. All right. What does this mean? Is this a trait that requires another trait to be implemented with it? What is this? Does anyone know what that is? That's what it seems to me, yes? Extends Bear. Okay, yeah. Bear, Texas. Oh, it's Bear, Texas. Sounds unbearable. Okay, that's what I thought it was. I just wanted to make sure I'm not a dum-dum and misreading it myself. Async function get keys. You go through here, DB resolves, B tree set key. Okay. The trait was separately implemented for Postgre, Squeal, and SquealLite by providing separate Postgre Texas and SquealLite Texas specific types, and both specific transaction types and the database backing it were chosen at build time where the database connection was established. Moving up from the business logic layer, the driver was parameterized on the domain specific Texas transaction so that it could have access to those operations and only those. Derive clone, driver D, where the D can be it can be send, it can be sync, it's static, let's go. It has all the things you want it to be. The implementation of the driver, you can get keys, which will begin, await, get the keys, commit, wait, okay keys. All right, cool. Note how in the above begin, the method recalls an instance of the transaction right away, ensuring that the callers always issue database operations as part of the transaction. This has been a deliberate decision from the very beginning to prevent issuing standalone database calls that could compromise the correctness of the data, because there was no scenario in which a transaction was not necessary. Okay, so that's why we do that. So you do the transaction, then you do the thing, and then you commit, and then it goes. Okay, cool. Finally, the upper REST layer took a driver as the engine to run the API request through. And as a consequence, the REST handlers all had to be parameterized with the underlying driver. Handler D, state driver is a state driver D. Wow. Implement into response REST error, where all of this stuff happened. Dude, don't you love this where business? Isn't this just so fantastic? Every time I start writing Rust and I start constraining these traits down a little bit, you just get the exact same stuff everywhere. It just starts, it's just like spreads. It just does not stop spreading everywhere. I feel the pain when I see this. The amount of times I've written this exact piece of code is beautiful. Where? TX equals trait expression. Does it? I think it equals transaction. TX equals transaction, dog. Doesn't equal trait expression. Right? Because you create a begin, which creates a transaction. The transaction does the operation, then you commit a transaction. There's no way TX equals trait expression. You need to get the hell out of here with that kind of talk. All right. Ensuring that the callers issue. Let's see. Hold on. Yeah. Oh man. I'm actually getting PTSD. I'm getting flashbacks right now. This is where things start looking finicky, because the REST layer now had to spell out the internals of the driver. Yes, it does. It's a leaky abstraction. That's why. But it didn't look so bad at the beginning. Combining this, the sunken cost fallacy. Ooh, everyone loves the sunken cost fallacy. Who here hasn't made the worst decisions of their programming life due to this? Right here. This guy. Right here. Right, this guy. Yeah, just read it out. Okay, just read it out. That right there. Every single time. Every time. It's just the worst. I don't know why I do it, but I do it every time. Every time I'm like, I've already done the work. Let's see. And the days devised how to make it above work. The idea of avoiding unnecessary abstraction at runtime made me plow ahead with this implementation. Let's go. The problems. It soon wasn't all roses. What you could see above was an extremely simplified view of how things ended looking like in a real service with more than just database dependencies. Without further ado, let me present to you the most monstrosity that I ended up with in the end tracker. Here's the driver definition. You know what the best part is? Is that every single person that takes in a driver has to copy this where statement. Oh, what's the plus? It just means these are trait definitions, right? So clone means you've had to implement the clone interface effectively. Send means you had to implement the send interface, the sync interface, the static interface, the clock interface. And so C is a clock that can be cloned, that can be sent across sync. It can be sent across thread boundaries. It's sync. It's static. Boom, 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 boom. Oh, but that's not all. Oh no, this chunk also infected the REST layer, which in theory should not care about the specifics of the driver layer. Here's the REST state. Here's every single endpoint he has to write now. All of them. All of them get this beauty added upon them. There are several problems with the above code. A, it's super ugly. Trademark that shit. You should have used the Unicode character. Just saying, bro. There is no other way to put it. As much as I like Rust, things like this are painful and scary, but not as painful and deranged as modern C++. Have you heard of our Lord and Savior, OCaml? These where declarations were repeated 44 times in 37 different files. Oh, gosh. Oh my goodness gracious. Oh my goodness gracious. Imagine needing to change one of those. You have to go find every single definition. I mean, I know LSPs make this modern LSP approach really easy. This is actually, okay, so this is where a text find and replace is actually better. It is literally better than using an LSP. right? Like, this is actually better than using an LSP. Oh my goodness gracious. But you'd have to have the same naming conventions everywhere you went to be able to find and replace like that. Whoo, boy. That is almost all files. This polluted source files with details they don't care about. Any small change in the driver requirement updating all of these repeated chunks in sync. I'm not even sure why Rust requires the duplication and why it's sometimes okay for the trait bounds to diverge among the various input blocks, but the duplication was necessary. 3, it poisoned the rest layer. As I mentioned above, the rest layer wants to pass around the rest state. Oh gosh, every time you pass that around, every effing time you pass that around, dear gracious of all goodness, object that contains the driver and other data fields are only necessary at that level. Yet to achieve this, rest layer had to replicate all these internal details of the driver. Yeah, see, again, this is just it's a perfectly leaky abstraction, right? This is a perfect leaky abstraction because it requires you to understand what's happening within the driver to be able to pass around the driver. I had to use a derivative to remove unnecessarily (clone trait bounds. The need to have clonable driver and rest state comes from how Axum HTTP framework dispatches route execution, and figuring this out took quite a while. Furthermore, the way this works is still obscure to me. Let's go. It became impossible to compose transaction types. This is a problem with my design and not an inherent issue with static dispatch. But the use of static dispatch guided me towards this design. Note that in the above, there are 2 database instances, D and QD, each with different associated transaction types. While I wrote some contortions to support sharing the same underlying database connections between them, I never got to replicating those to also share an open transaction. The complexity was already at an unmanageable levels to push this design any further, but I needed a solution to my problems. So this is where this is why garbage collected languages are really beautiful, right? This is why we all love garbage collection languages. Because when you hear this term, while I wrote some contortion to support sharing of the same underlying database connection between them, I never got to replicating those to also share transactions, right? Like, sharing a transaction is extremely hard, right? That's the reason why. Borrow checker just makes this type of stuff super hard, because the reality is it's really unsafe to do. It's very easy to get that wrong. And so it doesn't like it. It doesn't want that. Whereas, I mean, this is why I love what OCaml's doing. I truly do love what OCaml's doing with their local versus global approach to be able to add in lifetimes, but non-complicated lifetimes. And lifetimes are also orthogonal to the type definition, which means that you get this really speedy, amazing thing. Why would you even want to share a transaction? You could imagine multiple things doing, like, you could imagine a function that does each one of these, like, does each part of the transaction. I could imagine someone doesn't want one big ass function doing the entire transaction if you have a large one. I could imagine that happening, right? A stored procedure. I wouldn't want to do a stored procedure personally. This complexity was already at an unmanageable levels to push the design further. Yep. All in all, the use of static dispatch was slowing me down and building new features, as these constructs made me dread modifying each aspect of the code. And what's worse, certain initial design choices started showing up as true inefficiencies in production, like the inability to issue standalone database calls outside of a transaction. Yep. Transactions aren't free. The original goal of minimizing runtime costs was made significantly worse. Fixing these issues required a redesign, so it was time to a change. Switching to dynamic dispatch. Let's go. The goal with the redesign was to drop all static type parameters and replace them with the dyn trait objects. I've also had some issues with dyn trait or impl. In this way, the driver would encapsulate these details in just one place, and all other code would not have to care about the specific field definitions within this type. It was easier said than done, but the results speak for themselves. Now, let's see. This is how the driver simplified key value store looks. Okay, yes, because now you should be able to just say, hey, at the driver level, I need to be able to make it send and sync, right? It needs to be a DB that's send, that's sync. So it can do this, which means that the rest layer doesn't have to know that, right? The rest layer doesn't have to copy out these keys right here, because that definition stays within this dyn area, and this one doesn't stay within that. That's why people tend to use that, right? It makes it 10,000 times nicer, right? You don't have to know about that crap. You only know about that crap like because of the dynamic dispatch. Beautiful. That's it. The way to declare the driver over a generic database, the way to write business logic operation on top of this database, and the way to write REST API handler that calls into this operation. The arcs and the send sync annotations are somewhat ugly, but they are nowhere as ugly as the previous disaster. In this version, there is no noise. What's more, as part of the redesign, I could throw away everything behind a transaction idea and allow the caller to choose the best execution mode for the needs. Note, the text execution call above, which obtains an executor from the database and can be used to talk to the database. The specific call obtains an executor from the transaction, but the same DB execute method also exists and obtains the standalone executor. Describing how this works is out of the scope of this post, though. Okay, show me the metrics. Let's see some metrics. Everyone's favorite thing right here. Do you like, am I becoming annoying? Hey, can I get a real talk? Is the camel shilling becoming annoying? Tell me the facts. Okay? That way I can look at them and be sad. At the end of this, we'll look at this, okay? At the end of this little article, we'll look at the camel shilling and we'll see if it's sad or not, okay? Yes, annoying. No, it's not. Yes, it is. No, it's not. Don't worry. Don't worry. Don't worry. We'll fix this camel shilling very, very soon, okay? Don't worry. Don't you worry. All right, let's go to this thing. The pervasiveness of static dispatch in a Rust ecosystem helps leverage zero-cost abstraction, but it does come with a cost, namely programming time cost. It is great to have a choice, and it is great that many general-purpose Rust crates use static dispatch so that you don't have to pay unnecessary taxes. But it was not the right choice for me. I might have done things really wrong in my original design, and these measurements may not be sustainable for other projects, but let's look at the numbers anyway. So I do want to make one statement about Rust that I think is going to be a bit of a hot take, but I think is correct, which is the reason why Rust is so popular is that writing a library, even despite the complexity of static dispatch versus dynamic dispatch, despite all the complexity, becomes a very nicely packaged thing because it's a small library, a CSV reader. The runtime, like, it does not change. It becomes the thing it needs to be, and that is that. And so I feel like you can design this in its in its completeness. Whereas when you have an application, the moving target is where, like, for me, it's like it makes more sense to hit the clone button. It makes more sense to just go dine on that, right? It just to go more nuts on that and let the complexity remain in the libraries and let the ease of use remain in the applications. Okay? That's how I feel. I think that is the correct way to kind of approach Go development. Oh, no. Personal choice here. Code size. This is the refactoring according to Git staff difference. Okay. A project. So end tracker. Which one was end tracker, by the way? Lines added, lines deleted. Let's see. The changes to the 3.4 framework are small because the use of static typing within the framework itself, it wasn't pervasive. Yeah, exactly. Like I said, it's easy inside, right? Inside of a little framework, inside of its own little files, it's very simple. After all, the framework was just exposing the building blocks and not using them on its own. But the 11% of code reduction in NTracker alone is very significant. Let's go. Binary size. Looking at the size of the main NTracker binary and the supporting unit test binaries, both under the release and debug configuration. Okay, this is just sizing, right? Before, after, main binary, common tests. Okay, so they all go up slightly. Oh, this one goes down a little bit, but it goes up a little bit. It's about the same, a little bit down. Statistically, doesn't really matter. I was expecting a slight increase in binary size with the move to dynamic dispatch because the compiler and linker doesn't have as many opportunities for inlining and optimizing code. While the results seem to be all over the place, they seem to agree with my expectation. The binary sizes are larger when using dynamic dispatch. Some test binaries are smaller indeed, but this is most likely due to how the test changed, and not necessarily because of the switch from static to dynamic. Yep. Compilation time. I measured an incremental build after modifying the core type in NTracker codebase to change its internal layout, starting from cargo clean slate and using the mold linker. With static dispatch, the incremental build times of the binary and test were somewhere between 12 to 13 seconds, and with dynamic dispatch, they dropped just below 12 seconds. Okay, so I'd probably say that they're probably irrelevant, right? Whenever you see someone saying they're testing the build times just locally, just they're this close, it probably doesn't make a difference, right? If he would have said like 3 seconds versus 12, There's probably a difference, right? The difference is minimal, and the code base isn't large enough to obtain a good signal out of this metric. To be honest, I was hoping for a much larger improvement in incremental compilation times. My reasoning was that dealing with the type constraints that existed before must have been expensive, so removing them should reduce the compiler execution times. My measurement did not prove this true, unfortunately, or if they did, the improvements are negligible in this small code base. Refactoring effort. I spent a couple of days figuring out what the best abstraction was, and then I spent many hours during a recent long flight doing all of the mostly mechanical changes to the ntracker codebase. As usual, updating the tests was the most painful part of all, and also the one that gave me confidence to deploy a new build to production with ease. Nice. This is great. Runtime cost. This one, well, I haven't been able to measure it. None of my web services are CPU bound, so the cost of the virtual function dispatch is negligible. Boom. To summarize, not much seems to have changed with this rewrite. Binaries are slightly larger indeed, but not by a lot. However, the benefit in productivity are massive already. So I'm not going to lie to you. When I hear this, okay, I'm going to render a little bit of a judgment here. When I hear all these things put together, like nowhere near CPU bound, huge improvement in productivity. To me, this just sounds like use Go. I mean, I'm going to say OCaml, but you guys are tired of me shilling OCaml, so I'm going to go with Go. But I'm just throwing it out there. Like, unless if you just love writing Rust, like the point of doing this is writing Rust, which then at that point, use Rust, right? But if the point of this is getting things done, and you find yourself getting more productive by having to specify less types, go for Go. Go for OCaml. Go for something else, right? It's just like, if your goal is only productivity, there's better languages, right? And you are absolutely under no constraint of CPU. Like you're running on a nano node, just go for it. Because JS sucks. There's a reason why you shouldn't use JS, and JS sucks. Okay, that's why. JS sucks. All right. There's so many problems with JavaScript. I just absolutely it just drives me nuts. The amount of Rust and TypeScript compete for who can write the most type definitions. Okay? Rust and TypeScript. Go ahead. Develop a library. Even Theo did a video about this, right? He was all about, he had I feel like he had to write some library code and realize just like how much TypeScript can really get in the way. Stop with the negativity. JS is great. No, JS is not great. It's okay. Negativity is not bad. Okay, there's a difference between being a cynical person and pointing out something that sucks. JavaScript sucks. It's inconsistent. It has a lot of issues. There's all sorts of weird guards you have to do. TypeScript makes it better, but it also makes some parts massively more complex, right? The amount of type definition magic you have to do to write a good library is nuts. You can't just say that, okay? I'm sorry that you feel that way. To me, whenever I hear someone saying, no, you're just being negative, JavaScript is actually really great, what I actually hear in my head is, I've never really tried anything else, maybe like a day of Java or something, and Java sucks, so JavaScript's great, right? That's what I hear, right? It's just what I hear. I'm sorry. That's how I hear it. You know what I mean? Like, that's I'll always hear it that way. And I'm not trying to be a mean guy. It's just that's what I hear, you know? Like, I just get bored, right? JavaScript, I just constantly run into just some of the worst errors ever. One of the benefits of this rewrite is I've been able to finally resolve a long-standing deficiency in test coverage, which I briefly mentioned in the conclusion of the unit testing web server post. Ooh, interesting. This deficiency was that the test suites for the driver and the REST layer ran against SquealLite unconditionally, and I did not want to have to run them against a real PostgreSQL instance. Well, I have answered now. All it took was to switch dynamic dispatch and was to introduce a helper function like this. Connect to testDB. Do a bunch of the arcdyne blah, 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 blah. Get optional testDB. String must accept that. Dref, some postgre. Test utilities wait. SquealLite. Test doodle-doo. Init schema. Go. I use to connect a database in all tests and configure GitHub actions to do with DB postgre. To run the test suite against the production database. Another benefit is that I have finally unstuck something I've been working on and off for months, and I've been procrastinating on due to its difficulty. That is, I've been trying to generalize the account creation and session management pieces for the end basic service into 3.4 so that I can reuse those in ntracker. This was made really difficult due to static dispatch, but now it's a piece of cake, whichever means I should be able to add user accounts in ntracker really soon. or soon now, or end tracker really soon now, and maybe finally open it up to the public. Okay, interesting. All in all, I'm satisfied with the change. The code is much simpler now, and I do not have to foresee small costs at runtime nor in binary size to be a problem at all for my specific use cases. Boom. Again, this is great, by the way. This is a great article, and I think it just goes to show you that there can be some really significant costs when making things as performant as possible, right? Like, you should really have a strong reason to do this, right? Like, until you get to this point, like, you should never get to this point without the world's strongest reasons. You know what I mean? And so I just see this, and it makes me sad because at the end, he kind of outed himself as being like, well, this was kind of useless because he was just like, where do you say it? Well, actually, I wasn't CPU bound at all, so I did something to make it faster that isn't actually useful at all. And so it's like, it's a good exercise, right? He learned a lot from this, but at the end of the day, you did an optimization for a thing that did not need to be optimized yet. Right? Doesn't Rust have macros for this sort of thing? Not like that kind of macro, my friend. Only Sith deals in absolutes. No, that's a dumb phrase. There's plenty of absolutes in life, okay? if saying child porn is wrong, absolutely in all circumstances, then call me a Sith, baby. The name is I'm probably a Sith, baby.